Welcome to EDU World Space.
So the first one is to graph this, and I assume by the icon they have in the book, that means to just use like a calculator to do it. So the uh, three-dimensional calculator that I like the best is called CalcPlot 3D. You can just see the URL up top there. If you just type CalcPlot 3D into some search engine, it should pop up. So let me get rid of this. So if we want to do a parametric curve, we come over here and click space curve, and then we just type it in. So it would be sine of t for x, sine of 2t, and then sine of 3t. Then I'll just come over here, hit this, and then you can see that is going to be our curve. So you can see how it kind of like loops around. So if I'm just gonna start from 0 here, let me go ahead and hit go again. Okay, so you can see it still has the full curve, but if I were to do something less than 10, maybe like 4, you can see how I haven't quite got everything yet. So it might be something around like 7 or so. So you can see how t needs to be between 0 and 7 for me to get the full curve of this. So this is just something to keep in mind when we're going through and trying to actually evaluate this. So let's go ahead and first just start with t is equal to 0. So if this is supposed to be r of t, then r of 0 is going to be just 0, 0, 0. Now, the thing that we're looking for, because thinking back to what we had over here again, we don't just want to stop once we reach that spot one time, because remember, we still want to go past this. So we're going to need to find the second time we hit the origin again. So if we were to just go ahead and set this equal to 0, and it would be a good idea to set this one equal to 0. So it would be 0 is equal to sine t. So then this would imply, well, t is equal to 0. Then it's also at pi, and then it's also at 2 pi. And if we kind of remember what we said earlier, if we were to plug in, so first just pi, actually I don't know if I can just plug pi. Yeah, actually I can. You can see how this gives me that first loop. But then if I do 2 pi, it gives me the full loop. And then anything past this, it just keeps circling back in on itself. Because if I were to do like 3 pi, you can see how nothing new is really being added. So we have that. So this means when we're integrating, because remember our arc length is supposed to be the integral from a to b of the magnitude of our derivative with respect to time. So if we go ahead and take our derivative, we're going to get r prime of t. So we take the derivative of sine, so that's going to be cosine of t. And then the derivative of sine of 2t is going to be 2 cosine of 2t. And then the derivative of sine of 3t would be 3 cosine of 3t. Now we can go ahead and plug that in down here. So this would be the integral from 0. So we don't want to stop at pi, but we want to go to 2 pi of, and then the magnitude, we just square all these and add everything up. So it would be cosine squared of t plus 4 cosine squared of 2t plus 9 cosine squared of 3t. And then we take the square root of all this, and then d by dt. And I don't know if we can actually integrate this by hand, but I also assume since we were allowed to kind of use that graphing utility, and the previous ones we were also supposed to just like approximate it, you could either just go ahead and do like a Riemann sum for this, or you can possibly use some integral calculator, and that's essentially just what I'm going to do. So let me go ahead and pull that up really fast. Okay, so I have this integral inputted into, as you can see, just integralcalculator.com. And this is how I input it up here. Oh, actually, I need to close my brackets. So if you want to actually do where it's like an approximation, normally these wouldn't have anything there, so you just click on them, and then it would pop these up, and you write it off on the side. And then I just hit go, and I went ahead and already plugged this in because my internet's kind of bad, so sometimes it takes a while. But yeah, so here you can see it pretty much just says no idea how to do it. And then down here, this gives you the approximation for it. So the length of our curve is going to be something around 16.03.